Right, hi students, welcome back. We're doing part B of assignment 6, monomial theorem. And the last few questions of assignment 6 are mainly using the specific term formula, right? And yeah, I must say that they are not easy, all right? So do persevere through, because you will surely feel a sense of achievement, all right, after completing this assignment. All right, let's look at question 6. Okay, so for question 6, if you're going to take these factors, multiply with this, right, we're interested in x to the power of 6 and x to the power of 5. Okay, so if you're going to expand this term here, there's going to be 7 terms, which really not necessary to do that. We just need to find out what are the terms that we require to have to multiply with your 2x and to multiply with the q to get x to the power of 6 and x to the power of 5. Right, so what we're trying to say is that if you were to expand this, there should be 7 terms altogether, right? 1, 2, 3, 4, 5, 6, 7. Okay, so your 2x can multiply with all these 7 terms here. Right, but I'm only interested in x to the power of 6 and x to the power of 5. So therefore, we just need to minimize it. 2x, we just need to multiply it with x to the power of 4. Right, then you will get x to the power of 5, right? And we also need to multiply with x to the power of 5, because 2x means 2x to the power of 1, right? So 1 plus 4 gives you 5, and 1 plus 5 will give you 6. So we settled for 2x. Then how about q? The q is just a constant, so q will have to multiply with what term? Of course, you have to multiply with x to the power of 5, and also multiply with x to the power of 6. So basically, what is required of us to find from x plus p to the power of 6 are just your x4 term, your x5 term, and your x6 term. Okay, you just need these 3 terms to do. So you don't really have to expand everything out. We just need to know these 3 terms. All right. So that's find x to the power of 4 first. So we can use a specific formula. All right, so your a is x, your n is 6, your b is p. Okay, so if I want to get x to the power of 4, then I need to take 6 minus 2, right? Six minus 2 then give you 4, right? So in other words, my r has to be 2. Okay, my r has to be 2 because n is 6, right? 6 minus 2 give me 4. Right, so we're actually finding the third term. Right, so this you can just use a calculator. 6 choose 2, 6 shift n Sierra 2, that gives you 15 x to the power of 4 p squared. Okay, we write p squared first. So it's 15 p squared x to the power of 4. Okay, so we've settled for x to the power of 4 already. Now let's do for x to the power of 5. So to get x to the power of 5 means I need my r to be 1, because 6 minus 1 then gives you 5, right? 6 shift n01 is just 6. So 6p x to the power 5. Okay, so I settled for x to the power 5 already. I still need x to the power 6. So to get x to the power 6 means my r has to be 0. Okay, because 6 minus 0 then give you 6 ma. So 6 shift n00 gives you 1. So that is just x to the power of 6. P to the power of 0 is 1. Okay, so we have all these 3 terms ready. Now we are in business. So what do we do? I think I'm just going to erase this because I already explained to you the concepts. So now we can actually take 2x plus q, multiply with all our just 3 terms here. 15p squared x to the power 4 plus 6p x to the power 5 plus x to the power 6. Of course, there are other terms that you're not interested in. Okay, so we need to get x to the power 6 first. So this and this will give me x to the power 6. So that will be 12p x to the power 6. And q with this one. Okay, right. Then we are told that the coefficients of these two will give you negative 7. So from here, 12p plus q give you negative 7. So that's equation 1. Alright, then let's go on to find your x to the power 5. X to the power 5 will be getting 2x times this. That will be 30p squared x to the power 5. And then q times this. That will be 6pq x to the power 5. Okay, and we are told that the coefficients of this x to the power 5 is 0. So from here, 30p squared plus 60p cubed will be equals to 0. Okay, so we can factorize 30p out to get p plus 2q equals to 0. So since p is not equal to 0, we can just divide both sides by 30p. So from here, you get p is equal to negative 2q. And we call this equation 2. Okay, so we're going to substitute 2 into 1. And we would get 12 times p, which is negative 2q, plus q equals to negative 7. That will give us negative 24q plus q. Negative 23q equals to negative 7. I think there's something wrong with it. Okay, wait, I found my mistake. Alright, so from here, 30p squared plus 6 is 6, not 60, 6p cubed is equals to 0. So I'm going to factorize 6p out. That will give me 5p plus q equals to 0. So we are told that p is not equal to 0, so therefore I can just divide p on both sides. It's not equal to 0, I can just divide p on both sides. So therefore, q is equal to negative 5p. So that call this equation 2. So I'm going to substitute 2 into 1. And we will have 12p minus 5p equals to negative 7. 12 minus 5 is 7. Wait. What's wrong with me? Substitute 2 into 1. So 12p, q is negative 5p. So 12p minus 5p is equals to negative 7. 7p is equals to negative 7. P is equals to negative 1. Okay. So then to find the values of q, just substitute p equals to negative 1 into 2. So q will be negative 5 times negative 1 gives you 5. Alright, so this is how you do question 6. Right, let's look at question 7, part 1. Given that the constant term. Alright, so first of all, what do you understand by these two words, constant term? Correct, constant terms refers to the terms where the power of x is 0. That means we're referring to ax to the power of 0, where a is just a constant. Alright, the important thing is just to equate the power of x equals to 0. That's what it means by constant term. So if given is 7, find the values of positive constant k. Alright, so for these questions, we have to use a specific term formula. So what is a specific term formula? So the specific term formula, you can actually find it in the monomial theorem, which is this one here. Okay, so if you do a comparison with what you're supposed to expand, right, we can substitute your a to be x, your b to be negative k over x cubed, and n is 8. All right. Okay, so this one here, we need to separate it. To separate it, we can apply this rule. Okay, the only thing you have to watch out is because I have a negative there. So before, okay, one way is just to tag the negative with a k, all right, because we need to group all your x term together. So your x term must just be x and not negative x. So tag your negative with your k, so it will be just times bracket negative k to the power r over bracket x cubed to the power r. Okay, remember tag negative with your constants, do not tag it with your x term. Okay, so let's continue. So this one you can actually write it as x to the power negative 3. Okay, because let me simplify it here for you. Alright, this one means like this. Okay, so it means right. And this, if you were to write it as a negative index, means x to the power negative 3r. So this explains this portion here. Alright, so the next step is I'm going to group all my x term together. And this you can apply this rule. So that will gives you x to the power of 8 minus r minus 3r, 8 minus 4r. Alright, so we are told that the constant term is 7. That means we're going to let this equals to 0. So 4r is equals to 8. 8 is equals to 2. Right. So basically your constant term is your third term. Constant term is your third term. Right. So we're going to substitute r equals to 2 into this and equate it to 7. So therefore 8, choose 2, bracket negative k close bracket to the power of 2 is equals to 7. Right. So negative k to the power of 2 means negative k times negative k, that gives you k squared. K squared equals to 7 divided by 8, choose 2. You can easily use a calculator to work out. That gives you 1/4. Right, so therefore k can be half or negative half. But because you're told that k is a positive constant, so k equals to negative half will be reject. Or not applicable. Can put reject or not applicable. So k equals to half is the answer. Alright, so for part 2, we're supposed to use the value of k found in part I and to show that there's no constant term in this expansion. Alright, so we found k to be half in the part I. So to substitute inside here, what we have will be half divided by x to the power of 3. Change your half to times and then flip this fractions and you get 1 over 2x cubed. Right, so what we're trying to say is that if you're going to expand this diligently, you're going to end up with 9 terms. Alright, but of course we're not going to do that because it's very tedious. So we're going to show that when you take 1 multiply with all these 9 terms, plus if you take x to the power 4 multiply with all the 9 terms, and you simplify it, there is no constant term at all. So to understand that, you need to understand what is a constant term. So basically a constant term is just a term that can be expressed in the form ax to the power of 0, where a is any real number. A is any real number. So what we're saying is that when you take 1 multiply with all the 9 terms plus x to the power 4 multiply all the 9 terms, right, and you simplify it and you see that there is no such a term that's just circled. Every term will have x to the power of something. Okay, so we're going to do the reverse. What we're going to do is that we're going to show that there is some constant term. They are constant terms. So to get the constant terms means I need to take there are altogether 9 terms here. So 1 must multiply with one of them to get a constant term. And it has to be ax to the power of 0 because a to the power of 0 is a constant term. So 1 multiply with ax to the power of 0 and x to the power of 4 will, when you multiply with all the 9 terms, then one of them has to be bx to the power of negative 4. Because x to the power of 4 times bx to the power of negative 4 will just give you bx to the power of 0, which is b, which is a constant. Okay, so I need to fish out these 2 terms from this expansion. Therefore, I need to use the general term that I found in part I. Alright, so let's do it now. So I need to find this term first, which I'm just going to let 8 minus 4r equals to 0. Oh, I found it earlier on already in part I. Sorry, you're already given in part I that the constant term is 7. So actually, you don't really need to do that because it's already shown here is 7. But never mind, let's verify to see whether if it's really 7. So R is 2. So the terms we're finding, it's the third term. We found K to be half already, so just plug it in. And of course, 8 minus 8 will give us 0. Let's see whether we get 7 from there. So 8 choose 2, 8 shift NCR 2 times bracket negative half, cross bracket to the power of 2. And yes, we get 7. Yeah, it's correct. Alright, we get 7. Actually, we don't have to find it because already given in part I, but never mind. Then the next term that I need to find is bx to the power negative 4, which means I will need to let 8 minus 4r equals to negative 4. So 4 negative 4r will be negative 4 minus 8 negative 12r will be 3. So we're actually finding the fourth term. That will be 8 choose 3 negative half to the power of 3. And then 8 shift NCR 3 times bracket negative half to the power of 3. Get negative 7 x to the power negative 4. Okay, right. So what's happening now is that what we are saying is that 1 plus x to the power of 4 multiply with the 9 terms, I remember, and one of them is 7x to the power of 0. The other one is negative 7x to the power of negative 4. So let's see what happens if you multiply them. You will get 7x to the power of 0 minus 7x. Wait, hang on. I think I've done it wrongly. So what we're saying is that I've managed to find the two terms, right? The first term is 1 multiplying with 8x to the power of 0, which we found out to be 7. So 1 times 7. And then the second term is x to the power of 4. Have to multiply with bx to the power negative 4, right? And bx to the power negative 4 we found out to be negative 7x to the power negative 4. So you have 7 plus times minus is minus 7x to the power of 0. I get 0 because 4 minus 4 is 0. Right. And 7 minus 7 is just 0. So what does it mean by getting a 0? Okay, so what we're trying to say here is that the constant term that we assume there is actually cancel out each other. Because earlier on we assumed that there's a constant term, right? But this constant term actually cancel off each other. That's how we end up to get 0. So therefore there is actually no constant term. I don't know whether if you can buy that explanation. Because first of all, we started to say that there is a constant term. So we go ahead and find the constant term, right? Which is this one here and this one here. But what happened is that these two constant terms actually cancel off each other. That's how we end up getting a 0. So our assumption is wrong. Our assumption to say there's a constant term is wrong. Hence, there is no constant term. In the expansion, okay? Right, let's do the last question. Last question is classified as challenging. Let's see how challenging it is. First thing first, we need to do the expansion for this. So let's write down the binomial theorem. Alright, so let's do a comparison. So we can substitute your A to be 1, your B to be Px, and N is just N. Alright, so now we can do our substitution. So I would have 1 to the power of N, and then N choose 1, 1 to the power N minus 1 bracket Px plus N choose 2, 1 to the power N minus 2 bracket Px. And okay, because you're supposed to expand up to the term x cubed. So we need one more. And that's it. We can just stop it. Okay, so that's simplified. 1 to the power of anything is just 1. 1 to the power of 1 is 1. 1 to the power of 2 is 1. So basically 1 to the power of n will just give you 1. Okay, this one is a bit tricky here. Alright. I do have a video that explains how to evaluate that. If not, it's actually quite easy. Just substitute any values for n. So for example, you can substitute n to be 3. So if you have 3, 1, it means 3C1. And if you use a calculator, 3C1 is just 3 choose 1. Just give you 3. Okay, you can just try another number. Let's say we substitute n to be 5. So 5, 1 means 5 choose 1. And again, if you use a calculator, 5 choose 1 is just 5 shift n0 1, and that gives you 5. So in other words, what happened is that you will see the answer you get will just be this, the value. That means if this is 3, the answer you get is 3. If this is 5, the answer you get 5. So if you have n1, that means we're saying is n choose 1, and the answer you get will just be n. Okay, will just be n. So therefore, this one I can simplify it to be n. And this is just 1, because 1 to the power, whatever power is 1. So that will be 1 times px. And this I'm just going to leave it alone first. Don't evaluate first. This will give me 1. And this will give me px times px. That gives you p squared x squared. So that will give you p squared x squared. Alright, this one likewise I'm going to leave it alone first. That will be 1. And this will be px times another px. That gives you p cubed x cubed. So basically this is what we have. And this expansion, it's going to be equal to whatever that's given here, right? It's going to be equals to 1 minus 12x plus 28 p squared x squared plus qx cubed. Right, so what we are saying is, if you do a comparison, you can easily see that the first term 1 is equals to 1, and then the px term here will be equals to negative 12x. And this one here will be equals to your 28 p squared x squared. And of course, the last term here will be equals to this. All right, so we can divide it into 3 columns. Okay, we can compare the x term first. So the x term means npx is equals to negative 12x. Right, so from here we can just divide x on both sides to get np equals to negative 12. And we're going to keep that first. Right, now the next thing is that I'm going to compare my x squared term. So my x squared term will be this equals to 28 p squared x squared. Okay, so I can divide by x squared on both sides. You'll get this. Oh, I can actually divide p squared x squared on both sides. Right, the p squared and this and this and this will gives you 1. Divide by p squared x squared on both sides, that will gives you 1. So that is equals to 28. Alright, there are 2 ways of okay, I would rather that you learn the correct way. Don't do the trial and error. Some people would just try to substitute values for n. Like you try n to be 4, and if 4 choose 2, see whether they get 28. Or you let n to be 5, and 5 choose 2 whether they get 28. But then the proper way is that we need to learn how to evaluate this. So this one here, it actually can be simplified into n, followed by n minus 1, divided by 2 times 1. Okay, that I have a video that explain how you can evaluate this, where you can just, I'll post the link in the comments page, and you can just click on the link to find out more about how to evaluate and choose 2. Alright, so we can leave times 2 on both sides, and then expand your numerator. So 28 times 2 will give you 56. So you end up getting a quadratic equation where you can factorize it. Right, so you have n equals to negative 7 or n equals to 8. So of course n equals to negative 7 has to be rejected because n has to be a positive integer. So therefore n is equals to 8. Alright, so with n equals to 8, you can just substitute into the earlier one to find the values of p. So p would just be negative 12 divided by 8. That gives you negative 3 over 2. Then, okay, we still need to find the values of, wait, what else do I need to find? Oh, values of q. Right, so I still have to compare the x cubed term. So the x cubed term means n3 p3x3 equals to qx3. So you can divide x cubed on both sides, and you can substitute your n to be 8. And you can substitute your p to be negative 3 over 2. And from there, you can just calculate the q. Just use your calculator to calculate the q. So 8 choose 3 times bracket negative 3 over 2 to the power of 3. You will get q equals to, right, you will get q equals to negative 189. I think this answer is wrong. Okay, so I don't think this question is that challenging, right? The only thing is that it's challenging in the sense that you need to know the values for this. You need to know how to evaluate this one, which is equals to n. Also, you need to know how to evaluate this, which is just n bracket n minus 1 over 2 times 1. And then the rest is just relying on the algebraic skills. Alright. Right, so let's look at a summary of what are the concepts needed in this chapter on binomial theorem. Right, first of all, you need to know how to do simple expansion using the binomial theorem. Alright, that it's very basic. Number 2, right, these are some of the things you need to know, like n choose 0 means 1, like n choose 1 means n, n choose n means 1, n choose 2 means you can break it up into n bracket n minus 2 over 2 times 1. If it's n choose 3 means n followed by n minus 1 followed by n minus 2 over 3 times 2 times 1. Right, it's actually quite easy to remember. Right, if you have 4 here, let's say if you need to find n choose 4, let's just look at the denominator 4. So you start with 4 minus 1 to get 3, minus 1 to get 2, minus 1 to get 1. So there are 4 terms there. Then for the numerator, you start with n and n minus 1. N minus 1 minus 1 gives you n minus 2. And then n minus 2 minus 1, n minus 3. So you should have 4 terms at the numerator, 4 terms at the denominator. So if you n choose 3, can you see you have 3 terms at the numerator, 1, 2, 3, and 3 terms at the denominator. They're all in decreasing order. Okay, so what's the next thing you need to know? Right, you need to know how to use the specific term formula to find a certain terms. Right, the 8th term, the middle term, the 7th term. So you need to know what to substitute for R. And also sometimes you may need to find another, from the general term formula, find general terms in terms of R. Because R could be unknown. You need to find it when supposing you have to ask to find constant term, or you need to find the term x to the power 3 or x to the power 5, that kind of thing. So to do that, you need the knowledge of indices. So the two rules that we usually use, yes, will be this one here. So I've shown you how you can actually use it, especially when you have a negative here. Make sure you bracket it, okay? And then if you have so this one here, we are using this rule. If you have a over b to the power of n, this will give you a to the power n over b to the power n. And then you need to change this to a negative index. Okay, so these are the few things that try to master it well. It is very useful for solving problems on binomial theorem. And the last but not the least, of course, you need to understand when the questions require you to find the term independent of x, it means they're asking you to find the constant terms. So after getting the general term formula, you just equate the power of your x equals to 0 to find the values of r. And once you find the values of r, substitute back into your general term formula to get the independent term. Alright, so that's all folks. Don't give up. Alright, don't give up.